let's take a look at an example of evaluating one-sided limits. So if I have some function here, and it's equal to the square root of 4 minus x squared, and we want to see what the limit is as x approaches negative 2 from the right. So before we write this up, let's talk a little bit about why it makes sense to ask this question over any other one. Well, if you go back to pre-calculus or algebra 2 or whatever, you'll remember that if y equals this equals that square root, we square both sides, we get that y squared equals 4 minus x squared, with the one stipulation that y is greater than or equal to 0. And the reason is, the original case, that square roots can't be negative. That doesn't come out of it. So we have the case where y is greater than or equal to 0. If we move the x squared over, we have x squared plus y squared equals 4, which is a circle of radius 2, with, again, the stipulation that the y value has to be positive, or non-negative. So what we have is this circle of radius 2, and we want to figure out the limit as x goes to negative 2. Well, it doesn't make sense for x to go negative 2 from the left, because the function's not defined anywhere else. It's only defined in this region. So it makes sense to ask the question, what happens when we come from the right? So as x comes closer and closer to negative 2, the value of f of x becomes closer and closer to the axis, or the value of 0. So what we find is that the limit as x approaches negative 2 from the right of f of x is 0.